Hello students. Today we will be going over Chapter 11, the prerequisites, and starting on 11.1. For the prerequisite skills, it's on page 214. I'm going to have you do that page on your own. You should all know how to plot points on a coordinate plane. You should know how to convert decimals to fractions. Make sure you simplify those. And you should also know how to graph linear equations. So I'm going to jump to page 215. Our objective, I can identify linear and exponential relationships. Our vocabulary, a scatter plot. Scatter plots are another way of displaying independent and dependent data. Scatter plots show patterns in bivariate data. Bivariate means there's two variables, an x and a y. Regression, a statistical measurement that attempts to determine the strength of the relationship between a dependent variable, y, and an independent variable, x. It is important to select the regression model that fits the data, whether that's linear, exponential, or none. So with a positive association, notice that the points are, in general, going up. So if you have your graph here, you have your different points, and it's, in general, if I could draw a line, slope is positive. And it's going up and to the right. You won't catch every point, but you should get a lot of points right within that range and close to the line. And our exponential positive association is when you have some down here and then all of a sudden some of the points go up. So again, you won't catch every point, but a lot of the points will be right through that exponential. So again, exponential goes up like a half U for association there. Next, we're going to talk about negative association. That is when, in general, the dots are going down. So you could draw a line through it, and most of it's going to be right around that line as it's going down. So this would be linear negative association. Now, if it's exponential and it's a negative association, we have some up high here, and then we have some that'll be going down, and then all of a sudden the graph curves like that. That would be exponential negative association. Now, a no association is when, like the example here is how tall a person is and the amount of money earned each year. So here we go. So basically the dots are all over the place, right? So it doesn't matter how tall you are, that will not have any effect on how much money you make. Okay. Next, we're going to go on to page 216 and actually do one of them at the top of the page. Okay. Making sure you can see that okay. Again, page 216. Create the scatter plot. Describe the association. And then you have an answer bank here so we can decide out of which one of those it's going to be. So, you can't see at the very bottom, I don't think. Okay, so you should be able to see the numbers now at the bottom. All right, so it says create the scatter plot. 1, 100. So down over here, 1, 100. And I'm going to plot that point. And each time I plot the point, I can check it off or cross it off. I'll just put a little check mark. 1.5. Remember, I skip every other one, but it's going by 1. So I know this is 2 right here. So I go in between 1 and this 2 right here. 1.5 and 91. So 1.5, 91, right there. And then we go 2.5, 55. So 2.5, 55. Oh, that's right on that line. Okay. 3.1, 61. Okay, 3.2, 43. 5.1, 12. 6, 17. 8, 1. 9.5, 0. Oh, that should be 11 right there. So 9.5, 0.5, and 10, 1. So I say, what is going on? If I wanted to draw a line in between all those points, would it be curved or would it be straight? In other words, is it going to be linear or exponential? So I'm going to go ahead and draw a line, and then you could tell me. And again, you're trying to go in between all the points. So I'm going to go ahead and start up here. And then all of a sudden I see that it kind of curves that way. So which one of our graphs was that? What is the association? So, well, since it's going down, I know it's negative. So I'm going to say negative. And you should be writing this under association. It's going to be negative exponential. Okay. All right, I will leave those others to you. Now, I also want to talk about the wording at the bottom. Determine association from a regressive model if you have the equation. Okay. So 216 at the bottom. The value of an investment as a model is modeled by the equation y equals 2920 times 1.04 to the x. Now, if you see a little x up here, what type of equation is it? It's got to be exponential. That's correct. So the next thing you want to do is look at this number. So we know it's exponential, but we don't know if it's linear or whether it's positive or negative. So we know it's exponential. Now, if it's an exponential equation, you look at the base. This is the base right here. This is the exponent. Okay. Now, if the base is greater than 1, it's positive. Okay. And I probably should have used different colors than that. If the base is less than 1, it's negative. Okay, so we look at that base. Is that less than 1 or greater than 1? It's greater than 1, so it has to be positive exponential. Okay, all right. Now I'm going to go ahead and do number 12. The probability a team wins, and we have this equation, is modeled by that equation. Now we look at the slope. Okay, slope is positive equals, like it's a positive number, then it's going to be positive linear. But is that a positive number? No. If the slope, and again the y-intercept here won't even matter, and again this number in front wouldn't matter here for the exponential equation. If you get slope equals negative, then it's negative linear. And in this case, it'll be negative linear because it's solved for y, so I know that's my slope, there's my y-intercept. And again, the y-intercept doesn't make any difference. You can do the rest of these, students. You rock.